Hey, how are you all? I'm going to tell you about cheating Gall's law. First, I'm going to tell you who I am. How many of you have ever used NPM to install anything? Yeah, that's a lot of hands. How many of you use NPM just about daily? Yeah, that's a lot of hands too. This is why I love my job, because I run the registry team. So I am responsible for making sure that when you type npm install, something happens. You get the data that you want. So the story I'm about to tell you is relevant to all of you because it affects your daily lives when you type npm install. And the technique I'm about to describe that we used in npm is going to be useful to you all. The full title of this talk, Cheating Gall's Law, How We Split a Monolith and Lived to Tell the Tale. We just finished a big rewrite of the NPM registry. It was a successful rewrite, and a successful rewrite is such a rare thing to see that I want to talk about it and tell you how we did it. Let's start by telling you, how many of you know what Gall's Law is? I've ever heard of it. Okay, that's some. This is a great one. A complex system that works is invariably found to have evolved from a simple system that worked. How many of you want to argue with that? Yeah. It's pretty much a truism. Hold on to that thought. We're going to come back to this one. Let's talk about monoliths for a bit. Yay, monoliths. Richard Strauss plays and humanity evolves. But what does this mean in software? A monolith is a system, an app, with everything in one process. It's a slightly disparaging term for it, I think. But we all write them. They're really easy to write. They're easy to think about. They're usually easy to deploy because you've got one thing that you need to deploy. One thing goes into this app. And the other thing about monoliths is kind of nice, is that they're easy to squish around while you're discovering what your app needs to be. NPM started as a monolith, as many things do. Here's NPM's monolith. It's kind of a weird one, right? It's everything inside COUCHDB. COUCHDB is our database. You can put JavaScript inside it and have JavaScript run when things happen to the database, when people try to insert data or get data out. And that's how NPM was implemented. Used CouchDB's auth, stored package tarballs as base64 attachments inside CouchDB. This was just fine. Monoliths work just fine. When there were 10,000 modules, the secret is practically everything you do is going to be just fine. When your traffic is measured in minutes per request, you can do just about anything, and it'll be just fine when you're small. When you're small, the important thing for you to do is build a system that makes your users happy. This is by far the hardest thing any company or any team ever does. It's hard to make something that delights your users. I've seen companies talk themselves out of building the right thing for their users. I've seen people just mistake who their users are. Get this right first, because you don't have a scaling problem. And then something terrible happens. You've succeeded. Your next job is to survive your success. You remember the early days of Twitter? Many of you do, when Twitter was on fire constantly. They succeeded to a degree that was just very difficult to survive, and they did it, and that was awesome. So how do you survive success when you have a monolith? Yeah, you're going to need more monoliths. A whole lot of monoliths. I think the term for this is you're scaling horizontally. You make many copies of the full thing, and you load balance among them. If your architecture works with that, if your database can survive it, you're in good shape for a while. And sometimes you really, really, really succeed. Ever seen an exponential growth curve? That's an exponential growth curve. I've never seen one before in my career. It's kind of awesome and terrifying. This is NPM's package install curve. This is about when NPM started falling over. That's what it is today. 1.4 billion packages served every month. Last week, we peaked at 68 million packages served to you all on Tuesday. Yeah. What happened was that Node took off. You all started using it like crazy to do front-end development as well as back-end development. And so we had exponential growth. Exponential monoliths are going to be pretty expensive. Also, NPM's exponentially multiplying monolith was on fire at the time. So, like, imagine all of those burning. So we had to do something else. And this is often, like, you're going to find yourself at some point, you just need algorithmic change. You need to do something other than what you're doing. Your monolith isn't going to cut it anymore. So what you have to do is you break up the monolith. And this one's pretty trendy. Yeah, we're going to do microservices. Great. I'm not going to bludgeon you with a description of like why microservices are cool. Well, let's suppose you want them. Suppose they're the right solution to your problem, and you got to split your monolith. Just rewrite everything. Yeah, let's just do it. Your monolith is probably pretty complicated now. It's no longer that really simple thing you wrote when you got started, because you've figured out how to make it work for your users. You've added features to it, and they're the right features, and they're awesome. You know this because you're succeeding. So you got to rewrite it, and your rewrite has to have all of that new complexity in it. And what did that Gall guy say about complex working systems? Didn't we just hear something about that? Your rewrite is going to have to be a complex working system. Let's look at the law in full, because it's pretty cool. Complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a simple working system. This is from his book called SYSTEMANTICS. SYSTEMANTICS, it's a pun on the antics that systems get up to, how systems really work and how they fail. This is a really funny book. It's not really very scientific, but it's full of hilarious observations about systems in the real world. Gall was a pediatrician, not a computer scientist, but he was interested in systems found in humanity and how they failed. His key insight is that systems operate in a constant state of failure. He goes on to say about simple systems, they may or may not work. He's really encouraging. He also says, if a system is working, leave it alone, don't change anything. So this sounds like we've got doom and gloom here, right? We're stuck. We've got a complex system, it's working, what do we do? Gall's law tells us that our big system rewrite is probably not going to work out very well. We can't just rebuild the same thing from scratch, only split up into microservices this time. We have a word for this, second system syndrome. It's very bad. So how do you do it? What do you do? We did it. So obviously there's a way. I'm here to tell you what it is. We're going to cheat. You can't break the law. You still have to write simple working services first. So you know what we're going to do? We're not going to rewrite the whole thing. We're going to do it piece by piece. This one worked for NPM because we're a networked service. It might not work exactly for you, but if you've got a back-end service that takes network requests that you can do this with, this is gold. You can think about it from a code point of view, too. Here we go. You ready? Take a part of the system that you could think of as a feature, a small, simple thing. Slice it off into a module with a clearly defined interface. If you're lucky, you've got things with clearly defined interfaces already. You've got a subset of your requests that you can think about this way. If you're not lucky, you might have to do some work here. Make a module. Write a second implementation of the interface. Now that you've hidden the implementation behind an interface, you can do that. Do this standalone outside your monolith as its own thing. and then put a proxy on it. Send requests to the second implementation with a proxy. Let me show you a little diagram for you visual thinkers out there. Used to have everything going into your monolith. Now you've stuck a proxy in front of your monolith, and you just split traffic. One feature goes to one tiny service. Everything else goes to the monolith. I'll show you how NPM did this first, the first thing we did with this technique. So here's our monolith. Everything goes into CouchDB. CouchDB is on fire. Here we've split our traffic up with Varnish. I hear Varnish might be something you all know about, local. We put Varnish in front of it. That gave us cache. That was good. Yeah, caches are good. But we also split our traffic up into publishes and reads and tarball installs. We took all the tarballs out of Couch and stuck them onto a file system behind Nginx. The proxy sitting there meant that NPM clients didn't have to change at all, because we can't change the client that you all are using right now. That external interface has to stay the same. This right here, this little technique, stopped NPM from being on fire back in early 2014. Took about 90% of our CouchDB performance problems just out of the way. All right, let's get fancy, because that was kind of boring. You can put some logic into Varnish. You can do some, like, regex tests and stuff, but I think you get a lot more mileage out of proxy at the application level. Way more control and application level awareness. You know what your application is doing. You can be smarter about how you proxy. So this is what we did next. We put a service that we called the front door in front of everything. And you'll notice that it's like doing nothing right now. It's just sitting there. This is a great thing to do, because you measure. This is a great time to look at what your application is doing. This is particularly awesome if you've got a legacy service that you didn't participate in writing in the first place and you're kind of not clear on what it actually does. It's a great way to find out. Log everything. Emit metrics for everything. Figure out where your hotspots actually are, where you should put your attention first. Now, divide and conquer, one piece of your application at a time. You have the data. You know what's on fire. You know what the pieces of your monolith might be. So you do this technique one piece at a time. Define another interface. Make a second implementation of that new interface. Redirect requests. Here's what NPM's next steps look like. We took our user auth service, pulled it out, and we took package validation on publications and pulled that out as well. This wasn't a performance problem for us, but they were sort of gnarly implementation problems. The JavaScript that was running inside CouchDB is pretty tangled and hard to understand and full of side effects. So for these, we figured out what the implementation of the interface had to be and then rewrote them cleanly, trying to preserve as much of the initial behavior as possible. So the trick is, you beat Gall's law with modularity and information hiding. You think about modularity at like the code level all the time, right? What are the interfaces? Like, what should this module in NPM be? Try thinking about it at the service level as well. Each service is a module that has an API, an interface that it exposes, and you hide the implementation behind that API. It's the same technique. Modularity is the key to the kingdom of programming. You understand that, you can do a lot. So Gall's law is still in force. We still have to write simple working systems. It's just that we've chopped up the problem into smaller pieces. Each service is a simple testable system when viewed in isolation. So your overall system is more complex than it was, but you didn't get there by writing it all in one big project. You did it by taking a little piece of it, pulling it out, and working on it. And this is awesome. Once you've hidden your implementation, you're free to change it to whatever the heck it needs to be. I told you I wasn't going to sell microservices, but this is sort of the fun part of them for me. You can change your platform. We went from JavaScript inside CouchDB to JavaScript on the Node.js platform. We also changed how we store data. Take a look at this. We added some access control, and we started storing users in Postgres. Whoa. We're getting exciting with our databases. Okay. You want to see what the service looks like now? It's crazy cakes. But each of these changes happened slowly, over time, and under control, and we understood what we were doing at each step. Here's the thing. See that guy right there? Here, I promised I would use the later pointer. There it is. That right there is our monolith. It's still there, still more or less intact. It's this little beating heart that's been, thump, 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 thump in the registry the whole time. It's just that we've slowly reduced what it does until, at last, that thing is finally doing what CouchDB is good at. It's storing arbitrary blobs of JSON, and it's doing an amazing job of replicating outward and driving all of the rest of the service, which is just fantastic. All right, let's talk the good stuff and the bad stuff. All right, each piece is a simple system. Gall's law says you have to do this, so great. We have simple services, we can test them, we can debug it, one person can work on it probably, and you can develop them in isolation. More scaling dials to turn. This is pretty cool too, because instead of having to replicate our monolith, we can replicate just the piece of it that's on fire right now. For us, this turned out to be search. We were unaware of how much load NPM command line client search was putting on Couch. Didn't know it until we split it out. And then we were able to say, oh, we have to re-implement this. It's not implemented inside Couch. It needs to be its own service. So we did that. Now we have something we can scale on its own. Isolated tasks also let us debug. We found CouchDB bugs this way. We found other problems with our Couch app this way once we split out functions and were able to look at what they were doing on their own. The system looked like it was failing, but in reality, there was this one bug and this one tiny thing that we couldn't distinguish from general bugs with the system. You can still understand what's going on when you change something, because changes are isolated. The system itself is still pretty complicated, but you don't have to think about that complexity most of the time. And this is the most important thing. You have a working system every step of the way. You don't have to have a giant rewrite that has a boot up step where like, okay, now we can finally handle one request of the kind that the whole system needs to handle. Every change you make here, you've still got a system that worked the way the first one worked. You've still got a working app. You've just changed it out from behind people. The other great thing about the proxy was that you can flip back and forth between implementations. You can send a segment of traffic to your new implementation to test it out. We were doing this while we were testing the NPM registry. I would occasionally tweet, "You're soaking in it," when we were testing the new stuff, and then we would flip back. "You're not soaking in it anymore." All right. No free lunches, ever. There are always trade-offs. It's trade-offs all the way down. Here's one. This is fun. You had a distributed system before, but you were able to pretend you didn't. And now you can't pretend anymore. And distributed systems are hard. You have one that's entirely your own responsibility. We had race conditions. We had things that didn't quite happen in the order we thought they were going to happen, and we don't handle back pressure as well as we should in some circumstances. Requests will fail because the network is unreliable. This is complexity you have to deal with. Here's another really great one. I see you have a poorly structured monolith. Would you like me to convert it into a poorly structured set of microservices? This technique cannot save you from bad decisions about modularity. If you haven't figured out how to hide information, this isn't going to help you. You're going to have like tangled up microservices instead of a tangled up monolith. Second system. If you hear anybody say that, if you've ever said that in your career, run away. This time we're going to do it right. The problem is that you've just been through this pain. You wrote a thing, and it was simple, and it solved the problem, and then you discovered that you had to generalize somewhere. And that pain is fresh in your mind. You're like, I just had to change this to make this pluggable. That was horrible. This time we're going to do it right. Everything's going to be pluggable and configurable and completely repipeable from the start. Yeah, don't do it. Don't do it. Hold the line on this. Don't add complexity before you have to. Even though it's tempting, even though you remember the pain, generalize only when forced. Keep this second system as simple as you possibly can. It is the path to success. All right. I want you to put this technique in your back pocket. You might not be able to use it right away, but I want you to have it in the future. If next time you think about a rewrite, write your simple working service first, scale it later. Really, don't be terribly ridiculous about performance, but don't think too much about scalability at first. Think about survival by making something your users want to use. You'll be able to afford to scale it later if you're succeeding. Respect, Mr. Gloomy, pessimistic Gall. Rewrite in pieces. Use modularity to keep everything simple. Put a proxy on it. Proxy lets you divide and conquer by splitting up your interface. I like proxies. Proxies are cool. Be bold. You can do it. I've seen a lot of rewrites stall because people know that they're terrible, and they know that they fail, and they just let fear get in the way of doing something that you're going to have to do. You can do it. Change one piece at a time. It's totally approachable. You all didn't notice us doing this work. This is the thing I'm proudest of. We changed the entire freaking registry. And you all didn't notice. You just kept typing npm install. We had, and I counted it, 120 seconds of downtime during this deploy because 2 humans didn't communicate about whether something had been merged or not. Oh, those humans, they're terrible. But here's the thing. If I can do this, you can do this too. Because I've never done this before. But I figured out how to do it, and my team did it. My team is very smart, much smarter than I am. That's all I got. If you haven't updated your NPM client lately, do it. You'll be happy. It'll go faster. NPM loves you. Thank you.
It always looks so easy. When you show this, it's like, oh yeah, of course you do that.
Yeah, it was actually a lot of work. Yeah,
it really was. But you just make it look like, we just did this, and that was the natural order of things, and that's how it had to be.
I actually made that giant.
Was it really that easy?
No, it wasn't really that easy. I made that giant diagram at one point in the process because I was like, we're deploying this, and my production infrastructure was getting really complicated, and I'm like, what did we just deploy? So I made the diagram to sort of figure out what all the working pieces were, and I was a little terrified by it that we had done that.
So the question is, was each logical microservice autonomous, and could they continue working even when the others are down?
Generally not. What we split it up into, there's a little service in front of every database, a data source, a RESTful API service. And if those go away, if for example, you don't have access to users, things like publication will fail. Reads are still pretty, if you're reading data about a public package or getting a public package tarball, that will succeed almost no matter what else is down, as long as the front doors are up. But we're very redundant. We don't have one of anything. We have n of anything and can spin up n more. Even on a single service, we've got 4 or 8 processes.
Yeah, I like that curve you showed in the beginning.
Yeah.
You can go, oh, it's big.
Yeah.
So how do you sort of manage services? Like in terms of versioning or like dependencies?
Well, every service is an NPM module, and so it specifies its dependencies with the package JSON the way you would have any module specify its dependencies. And we have an internal registry private that we use to publish stuff that we reuse across services. We would use the public registry, but I don't want to have to depend on the public registry to deploy the public registry. So.
Probably a good idea. That sounds right. Architectural pattern-wise, that sounds right. How it should be. And there's a question, if you have any comments on the NPM folder structure and the long path problem on Windows.
Right. This. Part of it is like this is a complex one. My colleague Forrest, who works on the CLI, knows far more about this in detail than I do. But part of it is Node's problem, but part of it can be addressed with client problems. We have a rewrite of the client almost finished. It's in its final testing phases that by default installs into a much more flat folder structure. Like it will dedupe on the way in and put everything at the top level. And that was driven in part by an attempt to make things easier for Windows users by just making it less likely that you'll have, 50 levels of depths and trip that problem up.
Yeah, sounds good. You talked a little bit about metrics and performance.
Mm-hmm.
Did you already sort of measure and log everything, or was it things that you sort of put in place in order to make it easy for you to do the rewrite?
This was stuff we did in place to do the rewrite. I think it is possible to observe what's going on inside Couch, but we were not Erlang experts, nor were we particularly experts in Couch. So one of the problems with Couch was not knowing how long it was spending on any particular task. But as we wrote microservices, we have a little system where emitters, like something like Etsy's StatsD, where we emit JSON metrics to a collector, the collector then sends them into InfluxDB. So that was something we had to build out as we went. Log analysis is something we also do. We'll see.
So you built like tools and things to kind of measure.
I go into more detail about all of this in the talk I'm doing at One Shot Oslo. So if you're here tomorrow, I will talk about the stack in detail and what we've open sourced and what we wrote, what we use, that other people wrote, why we use it. So if you want the gory details of all that, I think there's one ticket left for One Shot Oslo.
That sounds exciting. I won't be able to, but someone else should snap up that ticket because that would be a good talk to listen to.
Right.
Thanks, CJ. That was awesome.